With unit circles is they're all about sine, predominantly about sine, cos and tan. And what makes these special functions is that they repeat over and over and over again. So a unit circle is a continuous repetition. It starts at 0 degrees or 0 radians and works its way clockwise. Okay. Positive angles, positive values go that way, clockwise, anti-clockwise. Whereas negative values go counterclockwise. Cool? So if I had sine of pi on 6, it would go there. If I had sine of negative pi on 6, it would go there. Happy with that? So it's all about sine, cos and tan. And let's bring back to SOHCAHTOA. What does that tell us? SOHCAHTOA, what's that telling us? Sine equals opposite over hypotenuse, cos equals, and tan equals opposite over adjacent. That's well and good. Where did we deal with that when we were in grade 9 and grade 10 and we first got introduced to SOHCAHTOA? Was it with unit circles? Triangles. And you've been exposed to these two triangles. They're very common. These triangles and this table are related. They're exact values. They're ones you need to know. Now there's two ways of doing it. You can remember the triangles or you can remember the table. Sweet. The way the triangles work is the shortest side is always 1. So on my top triangle, which is the shortest side? The bottom one. So that is given a value of 1. Happy with that? On this triangle, which is my shortest side? Both are my shortest side, so I give them 1. Do I know the hypotenuse of that triangle? What's the hypotenuse? Root 2. Very good. That's important. That one's easy. I find the 45-degree triangle much, much easier than the 30-60. Now, one of the things that I like to keep in my head is that I know that the other two numbers, does anyone know what the other two numbers on this triangle are? Yep. 2 and root 3. Which should be the longest or the largest of those two? Okay, you know it's 2, but it's the hypotenuse, correct? Some people don't know that root 3 is smaller than 2. So if you're unsure, what's something you could do to make sure of that? Put in your calculator, get root 3 out and see what it is. Happy with that? I think it's like 1.86 or something. So here we've got 2, and there we've got root 3. Very good. Are we happy with those triangles? Does that make sense? That doesn't help us with our exact values though, does it? Not initially. But if we go back to the definition of what sine, cos and tan are, we can get an idea. So we're going to fill out this table together using this information and the data we have here. I'm going to leave the 0 and the 90 degrees till the end though. So we're just looking at 30, 45 and 60. Firstly, which radian measure is 30 equal to? Pi on 6. For those of us who don't know how to convert radians to degrees, does anyone not know? We times by pi, divide by 180, or 2 pi divided by 360. Did everyone know that? The way that we do that is the way I like to do it is how many degrees are in a circle? How many radians are in a circle? So in a 360 degrees equals 2 pi radians. Cool. So 1 degree, therefore, if I divide both sides by 360, 1 degree, I multiply by that amount. If I want to go the other way, I'd obviously do the opposite, divide both sides by 2 pi. When I said pi on 180, where did that come from? It's just simplified. Sweet. So that's pi on 6, this one is? And this one is? To be honest, if you're doing it enough, you should be able to remember those. That's a good indicator. If you're doing enough practice, you'll be that familiar with those, and you'll know that pi on 6 is obviously the smallest amount. Cool? So let's look at sine 30, or sine pi on 6. So here I come over to my triangle. Now which triangle am I looking at? The top one or the bottom one? Top one, okay. My angle is pi on 6, so I'm putting a little star there. What's my opposite? What's my hypotenuse? So sine of 30 is 1 over 2. Same angle, let's look for cos 30. So my angle is still pi on 6. What's cos equal? Adjacent over hypotenuse. My adjacent is root 3. My hypotenuse, 2. So I know that cos theta equals root 3 over 2. Guess how we figure out tan? No, same triangle. Always the same. Well, that's still 1. Tan equals? What's the tan theta equals? TOA. Opposite over adjacent. So opposite's 1 over root 3. Clear with that? What do I do now? Go to my next triangle. I want to find out what sine of 45 is. Sine, does it matter which one I choose? Both the same angle. Opposite is 1 over root 2. Cos theta and tan. 1 over 1 is 1. Does that make sense? Let's just start picking this angle. Opposite's 1 over root 2, adjacent 1 over root 2, and tan is 1 over 1. Sweet. 60 degrees. Put a little star up. What's the opposite? Hypotenuse. So it'll be root 3 over 2. 1 over 2. Root 3 over 1, which is root 3. What I want you to do is well, actually, we'll finish off with my unit circle, and then we'll go through from there. So, I've taught unit circles a few different ways, and I'm still not sure which is the best way, but I'm going to give this one a go. I like to think of, we don't need our triangles anymore. They're gone. They're the only values plus the ones I'm meant to show us that we'll need to know off by heart. Everything else, you should be able to figure out. I like to think of cos x-axis equals cos theta. And I like to think of the y-axis sine theta. Now the thing about a unit circle is, what is its radius? What's the radius of a unit circle? 1. At all points in time, the radius equals 1. So, at this point here, what does x equal? 1. What does y equal at that point there? 0. So, what does that tell me about cos of 0? Cos of 0 equals? What about sine of 0? What does the y value equal at 0? Very good. At 90 degrees, so at this point here, what is my x value? So what does that tell you about cos 90 or cos pi on 2? That is equal to? What about sine 90?